In this video, I'm going to be walking through the variety of game details that we can configure when building out our game tree. This is going to be the most basic of the videos here in our game tree configuration because game details tend to be fairly constant. What I mean by game details are things like effective stacks and the pot size and the board details, which fortunately there's not a lot that we can actually get wrong in entering these details of the game tree. The board never changes if we are very clear on what we're actually trying to study and we're looking at a hand history. That board is going to be constant. We don't have any bias that we're injecting into this hand by adding a particular board. The pot size and the effective stack size, as long as we remember those details properly and enter those details properly, there's not a lot of nuance that can be added as it relates to entering those values. So they're required inputs to build a tree. And again, fortunately, these rarely change and they're easiest to properly enter. For the stack size values, I mentioned this in module 1, but a point to note here for the stack size values is that we can use any unit of measure. And you saw that from my examples in the previous video where everything was in the units of big blinds for GTO Plus, whereas for PioSolver, I did it in big blinds times 10. It doesn't really matter what unit I actually use, but I must remain consistent throughout the game tree. The stack size and the effective stacks don't matter, but the SPR, the ratio between the two, does. So that's the important component here, is that we have to be consistent with our units. In this case here, we also want to determine when some additional game details are required. So things like rake or ICM. We can and we should run tests to understand when these will have an impact on the output. And I get asked this question a lot, is when should I enter rake into my calculations? And we'll go through an example of this, but if rake is a significant portion of the pot size, or it can be a significant portion of the pot size, then I highly recommend that you utilize rake in your calculations. A good example of this might be a 1-2 or a 2-5 game that you might find in your local casino where they're taking $6, $7, up to $8 out of an individual pot, and each pot might only be $40 or $50. Well, rake is a significant portion of that pot size and is going to have an impact in the optimal hands that we should choose to play as it relates to range construction. So in those cases there, rake is going to be an important factor to add into the model to ensure its accuracy. Whereas if you are playing in a timed game where they're not raking individual hands, but they might be raking every half an hour, well, in those cases, then we would not be adding rake because rake is not going to be affecting things at that individual hand level. But the additional details that we might have, such as rake or ICM or things like that, that could have an impact here. So, and we'll cover that as we jump into the solver in a few minutes. Entering game details is actually a fairly simple concept here, so we're not going to spend a lot of time on these general considerations, but there are some things that we should keep in mind as we're entering some of these game details. First are some external factors that may impact the hand. So we've covered rake and ICM. Anything that is not necessarily inherent to the specific hand of poker that we might think of as it relates to bet sizing or ranges that could impact the output. Rake being one of those that we just discussed. ICM being another one where maybe we're studying a final table scenario or a final 2-table scenario in a tournament, and understanding ICM and including ICM into our modeling is going to impact the construction of hands that we might ultimately play in a certain scenario. We might want to include that within our overall model, especially given some high dollar value scenarios. So, something to just consider as you're building your game tree. If you want to make your model as accurate as possible, you may have to incorporate some of these external factors. The streets that we plan to study, Entering our boards, I tend to like to start on the actual street that I plan to study, as opposed to starting on a flop and then working my way all the way to turns and rivers. It's kind of semantics here, but what you'll find is when you start from flops, and if you're trying to study a turn spot and you start from flops and are working your way all the way to turns, you are taking equilibrium ranges. You're taking a solver output range of what the solver might do with the various hands on the flop and moving that forward towards the turn. You may not get the ranges that model realism that you would like to have. So I tend to like to actually put the board in of whatever turn that I actually want to start with and then work from there. And then finally, suit isomorphism. And this is a concept that I touched on briefly in Module 1, but you can actually model multiple game trees the same way. So there are 22,100 flops within the game of Hold'em, but we can actually reduce that down to 1,755 flops because of this concept of suit isomorphism. Ace of clubs, queen of diamonds, jack of spades is going to model the exact same way as ace of hearts, queen of diamonds, jack of clubs. It's just a rainbow board where the ace, queen, and jack are on the board. Suit isomorphism just demonstrates to us that it doesn't necessarily matter the particular suits as long as the overall structure of the board is the same from one hand to another. We can take the findings from any rainbow board and apply them to another rainbow board that has the same card ranking. So now let's jump over into the solver itself, where I'll actually configure the game details for our specific examples. So I'll see you over in GTO Plus first.